Hello everyone, my name is Rajat Kolecha and this is my ELL project. How a light interruption alarm works. This project intends to explain the internal working of a light interruption alarm which raises an alarm if the light falling on the detector is in. The prerequisites for understanding the mechanism of the light interruption alarm. Before understanding how exactly this device works, we need to understand an underlying mechanism behind the thyristor represented as SCR in the circuit diagram, and we also need to understand the IV characteristics of a thyristor or silicon controlled rectifier. A thyristor consists of three nodes to take an input: one anode, a cathode, and a gate. A thyristor basically is a PNPN diode, which can be also expressed as a combination of a PNP and an NPN diode with their NNP connected, or as a combination of two BJTs as shown in the diagram. A thyristor two transistor analogy. The two transistor equivalent circuit shows that the collector current of the NPN transistor TR2 feeds directly into the base of the PNP transistor TR1, while the collector current of TR1 feeds into the base of TR2. These two interconnected transistors rely upon each other for conduction, as each transistor gets its base emitter current from the other's collector emitter current. So until one of the transistors is given some base current, nothing can happen even if anode to cathode voltage is positive. When the thyristor's anode terminal is negative with respect to the cathode, center NP junction is forward biased, but the two outer PN junctions are reverse biased, and it behaves very much like an ordinary diode. Therefore, a thyristor blocks the flow of the reverse current until at some high voltage level the breakdown voltage of the two outer junctions is exceeded and the thyristor conducts without the application of a gate signal. If the anode terminal is made positive with respect to the cathode, the two PN junctions are now forward biased, but the center NP junction is still reverse biased. Therefore, forward current is also blocked. If a positive current is injected into the base of the NPN transistor TR2, the resulting collector current flows in the base of the transistor TR1. This in turn causes a collector current to flow in the PNP transistor TR1, which increases the base current of TR2 and so on. Very rapidly, the two transistors force each other into saturation and they are connected in a regenerative feedback loop. The IV characteristics of a thyristor. Once the thyristor has been turned on and is passing current in the forward direction, anode is positive, the gate signal loses all control due to regenerative latching action of the two internal transistors. The application of any gate signal or pulses after the regeneration is initiated will have no effect at all because the thyristor is already conducting. And characteristics of a phototransistor. When there is enough light falling on the base terminal, a base current is produced, which is proportional to the intensity of the light. The base current will then trigger the amplification process and a collector current with very high gain flows. The following image shows the collector current characteristics curve. Phototransistors are also available as three-terminal devices. In this case, the usage of base terminal is optional. When used, it acts as a regular BJT, and when not used, it acts as a phototransistor. The circuit diagram for the alarm. Working of the alarm. When the light falls on the phototransistor, which is usually the case, most of the current passes directly through this line, and therefore the SCR gate voltage is low and hence the alarm is not turned on. But when the light is obstructed, current does not pass through this line and instead goes through this line, and therefore the voltage of the SCR gate increases. Some of the current also goes through the SCR into the PNPN diode or the thyristor, and thereby triggering the alarm. The alarm can be reset using the switch S1, which connects the anode and the cathode of the thyristor, thereby turning the alarm off. Conclusion. Any obstruction in the light would thereby raise the alarm. And this device is used in museums and anti-burglary mechanisms to detect any obstruction in the path of the light. References. Thank you.